Looks like I'm live. Great, okay, so welcome to another edition of the stream about adding better grammar docs to CPython. So last time we ended up here. There's a lot of debug information in the current state. There's a line with a string representation of each rule. Then there's whatever the current tool comes up with, and then there's a dump of the structure in case the string representation isn't entirely accurate. And we have some simplification in. For example, here this expression option was removed because this one is expression and then something that's optional, and this one was removed too because it's also oh, this one was not removed, only this expression was put in front, and then everything here is optional. Right. So, let me get my bearing. Where are we? Working tree clean. Everything's fine. And what's the next step to do here? Actually, one thing to consider is, do we want to expose this gather syntax in the documentation? Because I don't think it's really standard grammar syntax. The full grammar specification says what it is. Match one or more occurrences of some expression separated by a separator. But I don't really think it appears in any other grammar descriptions. Certainly nothing I learned at school. Maybe we want to provide some kind of links to the syntax description. I think in the current docs it's briefly touched somewhere on this one of the first chapters. Syntax notes. Right. So the current docs have syntax notes in chapter 6 saying that we'd extended BNF notation. I think that's a term. Right. And this certainly doesn't have a gather expression, so we'll either need to use something else or document this. I guess it's best to document this and then provide links somehow. Anyway, that was a digression. The next step here is to start inlining things. Either start inlining things or start simplifying things, simplifying the code.
Do you want me to make a little note to, I mean, I don't mind. Do you want me to make a little note about coming up with a snippet for that? Documenting the gather?
Sure, if you want to. So,
Okay.
I think I have everything pushed in my GitHub repo. So, let's go here. And the branch name is Grammar and Docs.
Grammar and Docs, okay.
Right here. So if you clone my repo and go to this branch,
Yep.
you should have everything, and I guess you can even send a pull request to my repo. Let me
Sure.
put this in all the relevant chats if I can find them. Oh, now that I see the chat, I see you commented about the Snoop tool last time. Was it last time?
Oh, yeah, there's an extended, there's an enhanced project. PipeSnooper is like the original, the grandfather of them all, and then this other one, Snoop, is a little bit more.
Yeah. This looks
little
really
fancier.
fancy and nice. But I tried using it and went back to Prince again, to be honest.
Okay.
Probably
Mhm.
always does a bit more than I wanted to do. And
Sure.
I don't know. Maybe I want to analyze my feelings about it a bit more, but it seems that that I usually know what I want to see, and this just gives me all the information. So it might be useful, but
yeah, I think this was in the context of we were trying to display the contents of a big object,
right,
or something like that.
And also, I'm working on CPython, so I like using the tools that are directly in the language and see,
of course.
see what their disadvantages are and so on.
Yeah.
But if anybody's watching, it's certainly a good tool to know about. So what it does is that you put in a decorator like the Snoop. And then it tells you what the function does line by line, what variables gets assigned, what gets called. It has special support for a bunch of things like generator expressions or data classes. Yeah, basically somebody just put all the information they know how to extract into this tool. It's quite impressive. But for here, let's go back to top level components and maybe I will want to make the debug information optional and actually provide a command line option to dump it. Right? So that would be this from the peg generator and this dump tree. So let's go if debug. That's something I will want to pass in to generate rule lines. Wow, there's a lot of code now. Debug is debug, and actually this is the main function, so we have args. So debug would be args debug, and let's actually put it in here. The arc parser. I haven't used arc parser in a very long time. So let's refresh my memory. Add argument, action store true. Yeah, this is exactly what I want. So add argument debug, and I hope it also takes a help. Maybe we don't want the short option. I don't think people will use it very often. Let me add this to my invocation here. There we go. Okay, so it does this with the debug option. Without the debug option, it will only give us the what we want to see in the final docs. So that would be the simple stuff. Looks good. Now, one thing I wanted to do is to look at these simplification algorithms and simplify those. Because one thing I don't like about them is that whenever I create a new rule or a new node in the simplify method, I have to call simplify on that to get it simplified again, and that makes for some very verbose code, and whenever I forget to simplify, I get weird results. So I see two options to make that better. One is to run simplification in a loop until the simplified rule stops changing, which is rather a heavy-handed approach. So wherever I do simplification in here, so I would do last node equals node, and then while last node is none, and then while the current node isn't equal to the last node, I simplify it, but before that save the last thing. And now, because all of these things are data classes, simple comparison will work on them, and because I treat them as immutable, I don't actually change the internals, I always make new ones. This will actually work with the old state and the newly created new state. Hope that makes sense.
Fascinating. It does make sense, and I did not actually appreciate that nuance until you pointed it out.
Yeah, it's so I could do data class with frozen equals true everywhere to actually ensure that this I don't change this at runtime. So I can add frozen is true to all of these, and that will actually generate some very deep magic. Oh, maybe it's not very deep magic. It basically disables the attribute setter on the data class. I might want to re-enable the attribute setter afterwards, but I guess things work now with the frozen true, so let's do that. So I never forget. So these are now immutable. So this this little algorithm down here is correct, and what that means is I can remove the simplify from everything here.
Oh wow!
Right?
That's
remove it
pretty
from
slick.
everything here except well, I do need to call it once, and I do need to call it like in the simplify item. I do need to make sure that all the children are simplified at least once. But if they are, I don't have to then go through everything again. And that will make it simpler, but it will take some more time. Oh, instead of simplify, I can do simplify item here. It will take some more time to run the algorithm. Now that might not be a problem because these rules are like trivially small. So yeah, this should work. It should have the same result as before. I am getting some new debug info because I turned debug back on, but otherwise everything's the same, and everything here is now simplified. The other way I could do this is make new constructors that auto simplifies. I could do something like class method called new. Actually, I can do this in the base node, and that will call the class with the given arguments, simplify it, and return it.
Oh,
right.
That does seem a little more elegant.
So now I still have to remember to call this new. At all the places I remember, I just removed the simplify from. Usage-wise, it's not that not that much of a difference, I guess. Still have to remember.
Well, I'm not a big fan of remembering, so
Yeah,
I guess it doesn't matter much either way.
Me neither. Let's make it easy on the developer and a little harder on the machine.
Yeah.
Okay, so let's go through all the simplify. rules. So here's simplify item, which doesn't, which can be overridden in subclasses. It's called for each item. Here it's overridden. That's great. Simplify, called simplify item on each item, and no, nothing more. Decorator has one child and called simplify on that, and on nothing more. And gather should call simplify on both its children as well in simplify. So how do we do this? Self-type and right. Self-type, self-separator, simplify, and self-item. Right. Okay, so simplify is just called for each child. And since I always have only children as part of these data classes, maybe I could make this more generic. Nah, maybe not. This is fine. This is readable. Okay. So let's simplify in a loop to prevent forgotten simplify calls. Right, now that we have this, I guess it's time to start inlining stuff, and I will turn off the debug for this. So when I do something here, the terminal, it messes up the command line. I'll turn off the debug for this and see what needs to be done here. Right, so this statement needs to be in here. Statement new line needs to be in here. Simple statements need to be in here. And I guess the rule of thumb I thought about last time is whenever a rule appears exactly once in the set of rules that I'm documenting, then it gets inlined. So if expression was part of this little block of rules, it would not get inlined. It would be referenced here 2 times and then have its own line. But if I have something like this, then it gets put in, right? So the disadvantage of inlining is that we lose the name, right? So readers will
you lose the name. Oh, I see.
Yeah, so so instead of this, we have that, and it, oh, maybe needs parentheses, maybe not. No, it doesn't. Yeah, so the disadvantage here is it's no longer clear that this is like a list of expressions or a sequence of expressions. I don't think that matters too much in this particular case, but it's something to watch out for.
I see.
What I would like is to have a better way to represent this construct, because this is a sequence of expressions separated by commas with an optional trailing comma, where you can't only have the trailing comma if there, or where there needs to be one or more expressions, right? And this is not a very clear way to say that. Maybe we could use some kind of symbol to say, you know, expressions separated by comma. That's the gather. What was the syntax for the gather? That's in here. S.E+.
Oh, this is what we were.
Yeah.
Yeah.
So this, but it also has an optional trailing comma. Like that. So I guess we already have a syntax for that. Now what I dislike about this thing is that the comma here gets repeated. So if we had even better or even more, if we had syntax that's even more tied to our particular use of the grammar, we could have something that says, you know, there's a trailing comma here as well. Because I think that will appear a lot in the more complicated rules.
Yeah.
Huh. Well, let's simplify this first then. What are we looking at here? So let's just take this as it is and just special case it, or do I try to look for something more generic? So this is a sequence, so I can do some match magic, match items. Right, if len items 1, so that's a case where we only have one item. And now if we have some expression followed by, so this means optional, now inside that optional, I should really turn back debugging to have the names used in the code. So debug on, and that'll give us this. Maybe I should put in a wrapper to the debug output. More debug output. So this is the wrapper of what I'm looking at. Ooh.
Oh.
That's long, but we can make it shorter. So where was I here? So where a case where the items only matching items here. So there's non-terminal with value expression, and that doesn't need to be a non-terminal. That can be any piece of grammar. So I'll call that E1, and here's another occurrence of that. I'll call that E2. Ideally, I'd call it just E, and Python would ensure that they're the same thing, but we're not in a functional language, so I will need to say if E1 equals E2. And this was actually, I think, in the PEP for match statements. That's called out as a deferred idea somewhere. Algebraic matching of repeated patterns, right? So a deferred idea for the match statement is being able to have the same name here. But this is the workaround. There are numbers of subtleties involved with mixing load stores. So yeah, it's very complicated in the general case. Yes, what does comparison mean? How do you know if the two things are equivalent? Do I have equals here, or should this be is, or some other kind of comparison, right? Yeah, so we do have the workaround, unfortunately. All right, so in here we have optional, in which, so optional only has one item, so that. In the optional we have a choice, and the choices items are a sequence of one or more sequences of string with value comma, and this is the separator that I'm looking for. Right, so let's call that S1. The same thing will be here, so that's S2, and the same thing is here, so that's S3. Okay. Well, that's what we got. It's quite unreadable this way, but let's see if it matches. So, so that was this, and I want to make this instead. So that would be this a gather with the separator and the expression, and then an optional separator, right? So that's a sequence of gather with the separator, let's use S1, and the expression, let's use S2, and after that we have optional separator. Wow, it actually worked.
Oh, that's pretty nice.
So yeah, now instead of this thing, we have, ta-da, a simplified expression.
Is nice. Wow, that is much nicer.
That is. The problem is, this is not nice at all.
No.
So let's add some indentation. Does this choice end all the way here? Is this the correct indentation? Yes. So this would be E sequence of E separated by S with an optional S.
Okay.
Trailing.
Nice.
So the case syntax here is pretty powerful, but in this case is not as nice as it could be in like a functional language optimized for like this kind of destructuring. And I don't think there's anything to do about that. Oh, maybe there is. Maybe this can be broken up into the gather and the
separator,
like the gather here and then the optional separator afterwards.
Yeah, maybe.
Somehow. Yeah, maybe the simplification can be done in 2 steps, which would then be simpler, but I don't immediately see how. So this is well, even without the parentheses around it, right? So this general pattern means one or both of x and y.
Yeah.
But I don't think there's a good way to say that in the grammar. In the grammar language. There's also not a good way to represent this as a diagram. I think, at least with the diagram library I was trying out.
Yeah, because you almost want to say, you almost want to say it's a separator plus an expression, or just a separator.
Yeah. Well, not exactly. So this X does
I mean, it would
the
be
separator,
nonsensical. Yeah,
but
yeah,
generally this is like one thing and then optionally the other, or just the other.
right.
So you can have, and this is even not X. This is Y. Sorry. So this means you can have either X or just Y, or X and Y in that order, but
Yeah,
not nothing. Oh, you can have nothing in this case because it's all optional.
yeah,
Ah,
right.
right. So if this is all optional, that essentially means there's another case here. Well, that essentially means this is optional as well. So yeah, so both are optional now, right?
They are.
Okay, so maybe let's do that simplification first and see where that leads us. Except I lost the original thing here. So taking the whole thing, and what did I cut out of it? I took everything except the first expression here. So let's do that. So I'm matching only the items here. This would be the thing I left out for now. And now we have an optional choice of a sequence with one or more sequence of a separator and an expression followed by an optional separator, and yes, some of those got closed here. I don't exactly know which ones, and then their separator appears again, and this is wrong. That should be separator here. Yeah, so that's this. Right, so everything is optional. And inside there's a choice between a sequence of one or more. Oh, right. This whole sequence of one or more stuff is the X here. This whole yeah. So I'm calling this the Y and this the X. So it's an optional choice of sequence. Oh, right, this one or more is the X, and an optional Y. And here's just the Y. hope that's it. So yeah, I guess that didn't match. And that didn't match because it should, because I'm matching the items here. This should actually be in the simplification of optional.
Oh.
Right, I'm only simplifying one thing here. So if
oh, I see.
so if I'm having an optional choice of blah 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 blah, then I return a sequence of optional x, optional y. Otherwise I return super simplify. Did that match? I don't think it did. So there's something's fishy here. So optional here, something, an optional something, or a something. So it's a choice between a sequence of something and optional something else, and that's something that should work. Question is, does the simplify get called? Yeah, it's part of the sequence, so it should. Optional choice. Which one is it? And this one, I guess. Let's look at the structure here. So it's an optional choice sequence with something. Oh, and then there's a sequence with a comma. That's a problem. That won't match. There's a sequence with one thing that should be removed. That should be removed. In here? Did we lose the optimization somehow?
Sequence one or more.
Revert. What actually changed here? It changed to a match statement, and we're trying to simplify choice here now. This debug output might be useful. I'll stash everything else and start again. Because it looks like we're losing some optimization that was already there. And I hate to do that. And I think I'm too deep in, and I want to take another stab at this. So, this is where we are, and the issue is still here. This thing is a sequence, and it should not be a sequence. So what are we doing for choice here? So the alternatives we're using for choice are now lists of stuff. So we unpack the sequence and we treat any non-sequence as a list of one item. And right, and that means when we wrap stuff in sequences, we need to call simplify here. Calling the whole thing repeatedly doesn't help us, because we unpack we unpack all the sequences every time, and then we repack them as sequence, right? So doing this over and over won't get rid of this sequence, right? So I need to call simplify here, or I need to say, if alt only has one element in it, well, I won't wrap it. So this is probably simpler. Right. That's better. Okay.
Oh, that's so cool. Okay.
That's nicer. And now I should look. Well. Let's try to work with this. So this is an optional. Yeah, should be possible to work with that. Let me add this to Git. And now we go to this optional and match on it. So match self item, and if we get a choice between a sequence between something and an optional something else, yeah, this should be sequence. optional the other thing. Wait, no, this doesn't have to be optional. So this would be the y2. End of choice. Sequence needs to have a list in it. End of choice. If those y1 and y2, or y1 and y2 is the same, then we return a sequence of optional x and optional y. And if we didn't match anything, we return the super simplify. Let's see how that works. Nope. Well, something happened. Something happened, right? Here we go. Expression. An optional list of more expressions separated by commas and an optional comma. That looks rather good, doesn't it?
Yeah, I should say so.
Maybe it doesn't look as good as the previous one we were doing, but the good thing here is this is, well, this at least one fits on one line. Probably needs a comment. So this would be x, y, or y gets simplified to x, y. Right? Or in optional, there's a choice between x and y, and the other choice is just y, and we return this sequence. Needs to be spelled out like that because we are using Python syntax, but should be nice and readable. All right, so we have this. Well, we have this thing, and previously we simplified that to this thing. Let's look at the gather here. So gather is identical to some expression and then 0 or more of separator and that expression, which is exactly what we have here, isn't it?
I think so, isn't it? This expression.
Yeah. So there's one more simplification to make it the same, and that is if we have an optional 1 or more, that makes it a 0 or more, right?
Yeah.
So let's do that first, and here there are two choices to make. I could either do the simplification, like if it's an optional optional 1 or more, I return a 0 or more. Oh, yeah. Match. This should be case. I don't know my Python syntax. Okay, that's one more simplification to make. So this all now has a star. The other thing I could do here is just get rid of the 0 or more class entirely and represent that as optional 1 or more. That might make some of the cases here easier, but I think I like this better, at least for now. And I could get rid of 1 or more entirely and just represent it as optional 0. No, so get rid of 0 or more entirely. Always represent it as optional 1 or more. But that looks too complicated at this point. And now we have the definition of gather right here. The problem with what we have here is that we have a sequence of 3 elements, and only 2 of those are the pattern we want to simplify. Are you still following?
In other words, we wouldn't simplify more than 2 or less than 2?
Right, so what we want to do here, bring out the
Oh, I
again.
see. We don't want to simplify all 3. We only want to simplify 2 of them.
Yeah, we want to turn this into the specialized gather, right? And currently there's no way to match this, because if I go to sequence simplify, and I need to look at all the pairs, basically. Does that make sense?
Yes, because we don't, yeah. But we only have 1 pair.
Well, whenever we find this subsequence,
yeah,
then we want to simplify it. Now I wonder how to best do that. Well, I guess for starters, let's not make it too general. We can just go through all the pairs of the items and try to simplify each pair. So the pattern for going through pairs is zipping them up. So I go through all items and all items from the first one on, and I get all the pairs.
Wow.
Right?
Okay.
And now what I I want to do here is somehow called self.simplify pair. But I now need to be careful, because in the usual case, the simplified pair will not do anything. In this case, it wants to basically yank out this pair and replace it with a single expression, or more, but in this case a single item. Which means I don't want to then consider this pair, because I need to treat this thing as gone, as processed already.
Oh.
I don't know if there's an elegant way to do that. Maybe I just want to use a state variable. That I set at the end here. And I will be creating a list of new items here. And the simplify pair will return a result. And
what about okay, you wouldn't want to recurse down the tail, right, until you had nothing left?
Yeah, I do want to consider the tail separately.
Okay.
Well, either I want to consider the tail separately, or I could put in a special placeholder here. Right, but it's probably better to do it this way. So if I'm ignoring this item, so if I'm ignoring this item, I stop ignoring. Otherwise, I call simplify pair. So the default behavior of simplify pair would be to return the first thing and say that we are not ignoring the next item. And it's not immediately like obvious what this second item of the return value is, so I'll need to add a comment later. Oh, this should be items, of course. Now this results in no changes. That's weird. Oh, I need to add the result to new items. And I need to do extend because I might want to do more. So this will be a list of the first. Okay, and then I want to do replace items with new items, and what this will do is chop off the last item of every sequence, which I of course don't want. So at the end, if I'm not ignoring, then I add the last item to the end of the sequence. Oh, and of course, there's the case of not having any items at all, which I probably need to special case here. Okay, so this is a rather complex refactoring. It's a rather complex algorithm, and I'm not sure if I can find a more elegant way to do that. So let me try to describe this. Does that make a little more sense? Well, maybe a little. It's not a very elegant way to go around this, but I guess not all algorithms can be expressed elegantly in Python.
No, this is a nice note for the future. I mean, I think, you know, someone may well see this
and go, maybe I can write that
Yeah.
nicely.
Yeah.
Yeah.
Exactly. Yeah.
Okay, I need to go away for about 2 minutes now. So be right back.
Okay. Sure.
I'm back.
Nice.
Dad duty, taking the baby carriage up the stairs. And
Oh wow, that's great.
I did think of something that might be nicer. So let me stash this thing away and try another way. And the other way will be simplify subsequence. So I will simplify a subsequence, and this function will return what the simplification of some subsequence of okay, so this function will try to simplify the start of some sequence of nodes, and it will tell me how many it processed. Does that make sense?
It does.
So if I have the use case I have now, which is expression and then this 0 or more separator expression. Let's quickly write that. So the first two things of this subsequence are some expression and a 0 or more of separator and expression. Then I will return gather of the separator and that expression, and say that I processed both of those elements. Does that make sense?
Yes.
And now to call this function, I will again need new items, and then I will go through. So this is this is one case where I need to do range of len, which is something you should never do in Python. You should iterate over your sequence, but I'm trying to iterate over like ends of that sequence, like the first the full sequence, then the sequence without the first item, and so on.
Would you do enumerate? Do you use enumerate, or is that a different?
Yeah, I could use enumerate. The problem is I don't really have a use for this item. So,
oh, okay, right, I see. Right. Huh.
But
Then the other.
Here I won't be using for at all. Just occurred to me, because sometimes I want to skip more than one element. So I will start with the first index and then use a while. While the index is lower than the length of the items, I will do replacement and number of processed will be self dot simplify subsequence. Right. I will put the replacement in new items. And I will advance the index by the number of processed items. and then I will set items to the new items. And just to make sure I don't loop forever, I will assert that I processed more than 0 elements. So let's see what I got wrong. I think I got everything wrong. Everything's now a sequence with nothing.
Okay.
New wrong variable name. Yeah, there we go. So there's something going on here, and it's not the right thing. And that's because I need this replacement from simplify subsequence needs to be a list. Otherwise, when I put in a gather, unfortunately all my nodes are iterable, so I can easily get at their children. But if I use extend with a single node, that'll just effectively turn it into a sequence of those two nodes. I want to probably assert that replacement is a list. Right, and the resulting simplification is perfect. Right, so eval can take gather of expressions followed by a comma, and I hope this is correct. Let's look up expressions here. Yeah, it's not correct. Oh yeah, it is correct. It is correct. Good. Right. So yeah, there's a plus here. So yes, a sequence of expressions followed by an optional comma. Nice, nice, nice. Great, perfect. right. So I hope the comments are enlightening.
Yeah, I think they help.
So this would be...
I think it's great to have the video recording as a reference too.
Well, I don't know if anybody will want to watch this, so comments are very good, but so what did we simplify here? Basically, this is the definition of gather, so I'll use the definition of gather from here. So that is ESE star to S dot E S dot E plus right. Things are starting to look very good. Let me turn off debug. And marvel at the beauty of this simplification.
Yeah, indeed.
Nice. I don't know if this
It is very cool.
Before. Nice, nice, nice. So, there's nothing to do now except start inlining. So there's one thing that I should probably mention with these simplifications we've been making, and that's there's one thing I've been ignoring and that's relevant for the grammar. This is peg grammar, which means that the order of alternatives in a match matters. Right? So what happens is that the first alternative that matches is taken. And right, so if you're actually looking at the details of how the parsing works, then this is very important to keep in mind. So unlike grammars you would normally see for most other computer languages, this is like a quirk of this grammar that allows us to do very nice things like have parentheses around the context managers and with statements and a bunch of other stuff, but it does have this quirk. Now what I'm doing for the docs is ignoring this when necessary to make the docs simpler. It's not the only thing I'm ignoring. I'm also ignoring the look-aheads, the assertions and the invalid rules and stuff like that. So most of those are not important, like this one.
Okay.
I think this is a look-ahead. This only matches if type comment is followed by parentheses, but the parentheses is matched or something like that. It's probably written in here. Right. Succeed if E can be parsed without consuming enable. Yeah. So this is look ahead, which I'm also ignoring in the documentation. Same for negative look aheads, and this is called a cut. Those usually don't matter, and what I will want to say for the docs is, you know, if you want the full story, if you want like to follow with pencil and paper what the parser is doing, then you want to look at the full grammar, not at these snippets, which are more for getting an overview, an idea of what's happening. I don't want to reorder the matches too liberally, but when there's a significant simplification to make, I'm not afraid to do it. And I'm not sure if I did it now, today, but I don't really care. All right.
Okay. Nice summary.
So what happened here? Right, got rid of the debug output. Maybe I want to not use the debug output for now. Alright, so what happens now is I need to start inlining stuff. And I think I need to do that outside these node structures. Because so what I basically have here is a dictionary that maps a name to like grammar nodes, a grammar node, and what I have in here is a tree structure that doesn't have names attached, right? So this piece is not the same data type as the rule, if that makes sense. So I will not make inlining part of the simplification, because that needs to work with whole rules which have the name attached. And I don't think it would really fit the data model if I modeled the whole rule as a node. Always needs to be on the top level, so I will do that outside the simplify here. It'll make this part a bit more complicated though. So what I want to do is simplify all the nodes, and then right. So what I'm doing here, generate rule lines, is I'm getting a list of rule names, and getting the corresponding rules from the grammar, converting them to my little grammar nodes, doing the simplification dance, and outputting the rule into the documentation. And then I'm looking through that rule for all non-terminals that it references. And in case that that non-terminal is not documented somewhere else, I add it to the rule names to process. Right? When I want to do inlining, I'll need to get the whole set of rules up front, then simplify them, and then walk them and see how many times each of the names appears, and if it appears only once, then I go inlining. And
okay, I see. Right.
then I need to do the simplification again, because what will happen here when I inline simple statements is these three parts will all have a new line at the end, and I probably want to take it out and put the rest in parentheses, which right. So let's go through what will happen here. So I have this. This is simplified. I will see that simple statements only appears once here, so I will inline that. This goes away. Right. Next step will be this new line appears at the end of everything here, so I will put this in parentheses. There's nothing here. So so this is a choice with an empty option. That means the choice is optional, right?
Okay.
And then I'm done. Yeah, so I should simplify it like that. And then what will happen is statement new line only appears here, so it gets inlined, and I end up with interactive being optional compound or simple statements followed by a new line or an end marker.
And I guess for kids watching at home, these notes here could be like the ingredients for tests.
For tests? What do you mean by test?
In other words, you could basically use those as like the examples for unit tests, or I guess a functional test to make sure that you're making progress.
Oh yeah, definitely. What I'm currently using for tests is just looking at the result of the known output, and it'll stay this way because I have all the data I will ever need for this this tool. So it's the one case in software engineering that doesn't need additional tests.
Yeah. I meant if someone is using this for learning, then that's an example of.
Yeah, if you're writing a general tool, definitely write the tests for it.
Yeah.
Preferably first. Right, so I have 20 minutes for this, and I'm getting pretty tired. So I think this is a good place to call it a day.
Yeah.
And continue
Excellent.
next week. So next week, if I don't remember again, you can remind me that now is the time to start inlining. Can't put it off any longer.
Yeah.
So it's on GitHub. If you'd like to work on the docs note, as you said,
yeah. Thank you for the link to.
Feel free to send the pull request.
I will fork NPR.
I hope the note will still be relevant after this is done.
Well, it's not. That's okay. It gives me a chance to practice.
Right. Well, thanks for your time, and see you next week.
Oh yeah, my pleasure.